Hello, this is GeeklyEDU channel, and today we are going to talk about the derivatives. There are two main definitions of the derivatives. It can be the slope of the tangent line of a curve or the rate of change in a function. We are going to start by defining a function y equal to f of x. That can be any type of function. To find the tangent line to this curve at a point A, it will be necessary to define a nearby point B, being the coordinates in x, A, and B different. And then we have to calculate the slope of the second line AB with the well-known formula for the slope of a straight line. If we bring closer the point B to A and making the minuscular coordinate B tends to A, we get the slope for the tangent line. Therefore, the tangent line to the curve of a function f of x at a point A is a straight line that passes through the point A, with a slope m equal to the limit when b tends to A of the expression f of b minus f of A divided by b minus A, when the limit exists. We are going to find the equation of the tangent line of the function f of x equal to minus x cubic plus x in the point 1, 0. We will use the tangent line slope and the slope point form. If you don't remember the last one, you can study this topic in one of the videos of this channel called slope point form. Okay, let's begin. We know that the coordinate A is 1, and using the slope formula, we only have to substitute the values. In this case, m is the limit when x tends to 1. We have to evaluate the function when a is equal to 1, and then simplify the terms, and finally factorize the expression in the numerator to cancel x minus 1 with the denominator. Then we evaluate the limit, and we obtain that the slope m is equal to minus 2. Now, by using the slope point form, we substitute the values of the point A and the slope to obtain the tangent line y equal to minus 2x plus 2. We can simplify the expression of the slope of the tangent line in a point of the curve defined by f of x if we substitute x minus a for h, being x equal to a plus h. In this case, the limit of h tends to 0, and the slope exists when the limit is well defined. As I told you before, we can study the derivative by the rate of change in a function. We are going to do it by using the case of a car moving a distance in a period. Imagine that we are visiting a friend who lives 200 miles away and we have to drive a car. We start our trip, and after 2 hours, we have to stop at the gas station and use the restroom, maybe buy an ice cream or something before getting back to the road. Then we drive again until we stop to eat at a restaurant for about 45 minutes, and finally driving to our friend's house. From the moment we left our home to the moment we arrived to our friend's home passed 6 hours. So the average velocity is the total distance divided by the time. That is 33 miles per hour. But we know that we stopped twice and didn't move at the same velocity all the time. Therefore, the velocity is not correct for all the moments of the trip. If we want to know the velocity at every point of the trip, we need to know the rate of distance in certain time. And that is called the instantaneous velocity. If the trip can be defined by a function of time, then we can study the velocity in every moment of the trip. If we rewrite the problem that we already studied in terms of maths and defining a function r equal to f of t as a function of position that depends on time, then we know that the instantaneous velocity is the limit when h tends to 0 of f of c plus h minus f of c divided by h, being c an instant in time, and this is true when the limit exists. From the concept of the slope of the tangent line and the rate of change of a function, we can say that the derivative of a function is another function that describes the rate at which a dependent variable changes with respect of the independent variable. This concept is the basis of differential calculus, and this is just the first video in this topic. Press subscribe so you don't miss our next videos, thumbs up, and share the video with your friends. In the next videos, I will give you some tips to derive many types of functions and some rules that you should not forget. Thanks for watching and see you soon!
We hope you liked this video. Don't forget to press subscribe, give us a thumbs up, and stay geekly.